Hi everyone. So let me just give you a quick definition. What's a polynomial function? You've seen many of these before. It's simply a function that is made up of independent variables, or x's, that are raised to some positive number, like x to the power of 2 or x to the power of 3, and so on. You're familiar with quadratics, which is x raised to the power of 2, as well as linear functions. So let me show you what happens if we have y equals x raised to the power of a higher number, like 3. Have a look at this graph. I'm just on Desmos. If you want to head over there now and enter your own function raised to the power of 3, go ahead, because we can play around with this. Look at the shape of this graph. How does it look like a parabola, and how is it different? You may notice that it starts from the bottom left quadrant, it reaches the origin, and then it continues on to positive, what we'll say, positive infinity, right? This graph doesn't really end, it just keeps going, much like a parabola does. But you may notice a difference in its shape. And that's important because from here on in for the rest of this unit, we're going to see what happens if we transform this function. This is called a cubic function raised to the power of 3. When we apply the same types of things we did to a parabola. So on your Desmos screen, see what happens if we change the leading coefficient to a negative. If I do that there, you'll notice how this graph suddenly reflects itself. So it's starting from the top left, it descends, it still passes through the origin, and then it continues on down to the right. So it's a very simple transformation. It's still a cubic function. And you can imagine what will happen if I start to add and subtract things to x to the power of 3. As long as the highest exponent is 3, the function is still called a cubic function. So I don't want to do something like add x to the power of 4. That'll be changing my function completely, and we will see what that function looks like later on. But what if I just add an x, and then possibly add another number, like 3? You can see this function has been translated up, and it also changes its shape locally around that y-intercept, which is 0, 3. So there's nothing right now that you need to know specifically with transformations. I just want to give you a taste of how this function looks when we start adding and subtracting other terms to it. So this is a cubic function. Welcome it. And we're going to see what happens in the rest of this module when I ask you to examine the end behavior of a function. Now, that word did come up in the prerequisite skills package. What that's really asking you is what's happening to the polynomial function at the extreme values of x, meaning when x is really, really large in the negative direction and when x is very, very large in the positive direction. What happens to the graph? Well, this one's easy, even if I get rid of these extra terms here. Let's make that leading coefficient positive again. What's happening to this graph? Well, it starts very, very, very negative. So I can actually call this end behavior negative infinity. Right? This graph doesn't really reach a number. It just keeps going down and down and down as x gets larger in the negative direction. Now, if we look to the other side, if x gets positive and it gets larger and larger, what's happening to the graph? Well, this line keeps going to positive infinity. So I can say that its end behavior as x gets very large is positive infinity. It keeps going on forever. There's no finite number that graph will ever reach. So that's what's meant when we talk about end behavior. And you're going to see in the next couple of examples and another video more details as to how you can describe it.